Assalamualaikum warahmatullahi wabarakatuh, and very good day to everyone. Okay, next we'll try to solve another problem related to simple harmonic motion. Okay, given the problem, an oscillator is made up of a wooden blocks of mass of 0.80 kilogram that is attached to a spring. Okay, we have a spring attached to a wooden blocks. Mass is a 0.80 kilogram. Okay, undergo simple harmonic motion. So with amplitude 0.4 meter. So amplitude is a 0.40 meter. Okay, and the period of the oscillation T is a 0.40 second. Okay, question us to find the angular frequency of the oscillation. So when the spring is attached, when the spring is stretched, so the angular frequency, we can get the answer by using the formula, which is angular frequency is the omega equals to 2 pi f or 2 pi over t. Since we have the value for period, so we need substitute into this formula. So 2 pi over 0.40 second. So the answer for angular frequency of the oscillation is a 5 pi, the unit is radian second minus 1. Okay, next the question asks to find the spring constant, which is K. So K, what is the value for K? Okay, from the formula angular frequency, we have another formula on angular frequency, omega equals to square root K spring constant over M. Since we have the value for omega and we have the value for mass, which is 0.85 kilogram, so we can find the spring constant by using this formula. So from here, K is a omega squared M. Okay, omega squared M. So substitute the value of omega, 5 pi squared. Okay, M, the mass is 0.8. So the answer for K is a 197.39 Newton meter minus 1. Okay, next the maximum velocity. Okay, for maximum velocity, we have the formula. Okay, maximum velocity, we have the formula. Okay, V max equals to omega A. So omega is 5 pi and A is the amplitude, which is 0.4. So we substitute here 0.4. So for maximum velocity, the answer is 6.28 meter second minus 1. Okay, next is to find the maximum force. So maximum force, we can calculate by using the formula F equals to K A. Maximum force equals to spring constant times A. So the spring constant value 197.39. The amplitude is 0.40. So the answer or the maximum force is 78.96 Newton. Okay. So next question asks to find the potential and kinetic energy of the system at a position of 0.2 meter from the equilibrium position. Okay, so to find the potential and kinetic energy, so we have the formula for potential energy, which is U equals to half kx squared. Okay, and for kinetic energy, we have the formula equals to half mass times mass omega squared A squared minus x squared. Okay, so question asks to find at a position of 0.2. So we substitute this x with a 0.2. So for the potential energy, so we have half times k. So k value is we get from the previous, from the B, which is 197.39. So k is 197.39. Okay, x is 0.2. So x 0.20 squared. So you will get the answer is 3.95. Okay, the unit for the energy is a joule. Okay, next for the kinetic energy, the same method, we just substitute the value. Okay, for k, half. Okay, the mass is 0.8. Okay, mass 0.80. Omega, we get from the A, which is 5 pi radian. So omega is a 5 pi squared, and x is a 0.2 squared. So we calculate this answer, you will get sorry, for this one is wrong. Okay, wrong substitution. Okay, so omega, we have the 5 pi, and A is the amplitude, which is 0.4. So for K, kinetic energy, half. Okay, the mass is 0.80. Omega is 5 pi. Okay, 5 pi squared. Amplitude, okay, from this given the amplitude is 0.40, then x at the position 0.2, so 0.20 squared. So calculate this one, you will get the answer is 11.84 joule for the kinetic energy. So the last question asks to find the total energy of the system by using the answer from E. For simple harmonic motion, for a spring, the total energy, we have the formula. Total energy must include the potential energy plus kinetic energy. So from here we just substitute the potential energy value 3.95 joule plus 11.84 joule. So the answer is 15.79 joule, the total kinetic energy. Okay, that's all for this kind of problem. Okay, you can try by yourself. Okay, good luck.